At the high level, we have client which are interacting with our service. This service, they are interacting via the APIs which we have discussed. API, the post API, the post API for shortening. Similarly, the get API for shortening the long and short URL. This service is saving these mapping into the database. Client is making the request to service, and service is saving the data through this API to the database. And the schema what we have discussed here are the user and the shorten database table on which these records are being saved. And also there is a unique ID generation part. So here we can have another service which is abstracted how these unique URLs are being generated, right? So unique ID generator, there is one service which is generating the unique IDs. With this unique IDs, this service is doing append on the domain name, saving into this with the mapping of the original URL. And when we get the get request with the unique IDs, the service can search into the database table and then return the long URL as a response to this client. So this is a very high level on the data flow, how the data flow would work. Now we will get a bit on the deep dive section. Let me create some space for the deep dive. Let me keep it in the bottom here, and let me move this little down here so that I can get space for the problem statement which we will see now. Okay, so the basic flow would work fine, right? But for the scalable system, right, when we are getting hundreds and thousands of requests, so here let's try to identify the deep dive discussion pointers here, considering the scalability and security in our mind. Okay, so the first area which we can focus is when the URL is already being shortened, right? So we wanted to see if we get the same request again from a different client, do we wanted to duplicate the record into this database server? If not, then before creating it, we can check into the database. Do we already have these URL being generated? If yes, then just return that in the response. If not, then create it. That is one area. Second is when we are getting thousands, hundreds, thousands, or millions of requests, right, within at the same time, to basically create the URL as well as to read the URL. So you see the read versus write ratio, what we discuss is 1:100, right? So when we are getting the write operation into our DB, we are maintaining the consistency. So probably we might wanted to log the particular row, or the block the table when we are writing, or in fact we do not want right to the write which is happening where we are basically guaranteeing, right, where we are providing the guarantee to the customer that your write is happened, right? And there we are doing the trade-off with the performance of the system. We are taking some time to write into the system and then sending back the response to the user. With the first category of the users, the second category of the users who are doing the read operation, there we wanted to prioritize on the performance of the system, right? So we do not wanted to have the same access pattern for read and write. For that purpose, what we can do is we can have a read and a write replicas for our DB instance. So let me create another instance of this DB and let me call as read replica, and this is a write. So the schema would be the same for both the instance of the server, right? But the difference is just between the read and write, so that this database instance can scale on its own. So at a very hypothetical number, since we are having read as 100 times more as compared to write, so we can have 100 instances of the read databases instances and one instance of the write. So this we are scaling in terms of the cost optimizations and also the optimizations on the performances, queries. These all can be handled separately between these instances. But with that, we get into a second set of problem. How do we keep this read and write in sync? So when we get a request, we can have a eventual consistency or a strong consistency. Strong consistency would mean that when we are writing to this instance, we will be writing into this instance as well, right? If one of these would fail, we will roll back the another instance. With that, we are sure either the write happens to all or none. It will take some time for this service to write into the multiple instances. We are providing the guarantee that we are writing to all the instances. So whenever there is a read by a different customer on this instance, they are gonna get the data at that point of time. So this is a strong consistency. If we are going ahead with the eventual consistency, what does that mean is we will not write here directly. We will just write into this instance and we will not write to any more database instances, right? And this replicas in sync we do asynchronously. We could run a kind of a cron job which periodically reads, let's say, every minute and writes to this instance, right? Or we can perform some kind of a trigger as well. Whenever write is happening into this, it will create a trigger and write into these instances. So this is a eventual consistency. What does that mean is, this instance, when some customers are reading directly from this replica, they will get the record eventually at some later point of time. Might not be that specific point of time. They will get the record, they will read from this instance, but eventually. Do we need to always hit our database where we have the millions or billions of record from like last 5 year, 10 year, right? So no. So what we can do is we can introduce the Redis cache here for the read cache, memcache or Redis cache based on your expertise. So here we can introduce a cache. So whenever we get a read for this service, first we can check from the cache, do we already have the shortening of this URL, whether it's a long URL or short URL. The mapping data is already available in the cache. We can return back to the client. If not, then we can go and hit in our database instances to get the matching record. Then we get into the same problem again. If we having a cache miss, if we do not find into the cache, we read from the database, we write back to the cache for some other client for a later stage. Then here also we are taking some time, right, for the request whenever we have a cache miss. Is it a eventual consistency or a strong consistency? So if we are doing as a response, we are writing to the cache, it would be a strong consistency. Let's say we just introduce a layer of any message broker, for example, Kafka here. Okay, so we introduce a Kafka layer in between so that we do not have to write to these systems with a strong consistency, and all these system is eventually written with the use of the Kafka. So same applies to So to this whenever the writes are happening, we are just writing into the Kafka and we are not actually writing to the database instance. We are just writing to the Kafka and some services consuming the messages from the Kafka and writing back to this readdb and the cache so that it can be used at later stage point of time. uh, I'm not introducing any other service. So let me introduce one more service here, which is, let me call as a sync service. And this is consuming the messages from the Kafka with the eventual consistency and writing back to these instances for the read operations. Uh, I hope you are able to understand this. So let me quickly go through it. The request would come for the write. It will generate the unique ID number for that specific long URL. It will save here with the eventual consistency. It will put into the Kafka. One message it will put into the Kafka and just return back the response to the client that this is your short URL. The client would share these short URL to different set of customers. Those customers will make another GET request to this service. Okay. By then, this service would have consumed the message from the Kafka and returned to this cache and to this readdb instances. Okay. Now that request came from the second set of customer for the short URL and the customer needs the long URL in the response. So first we will go and check the cache. Yes, we have found that URL, right? If this service has not written by then we can go to these read dbs or write dbs as well, right, as a backup for that. But in case if you have already got the mapping for that long URL, for that short URL to the long URL, we can send back the response to the customer, right? Similarly, if there is a cache miss, we can go to the readdb and pull this information, update eventually to this Kafka and send back the response to the customer. The third customer comes again. By then this service would have consumed the message and updated the cache here so that for the third or fourth customer can get from the cache. So this would consider the multiple scenarios. Here we have considered the scalability part and started with the strong consistency with the high level system design here. But in the deep dive, we wanted to prioritize the performance of the system for the read, for the scalability purpose. So for that reason, from the strong consistency, we went to the eventual consistency. The reason here getting a trade-off with the eventual consistency on read is because if you think about the use cases for the URL shortening service, the URL is creating once, right? And it's okay for that URL to be available after 1, 2 or 3 seconds, right? For hundreds, thousands, millions of customers. It's okay to be available after a few seconds, right? But once it is available, we wanted to prioritize the performance. But whenever we get into the eventual consistency, we also opens up another door for keeping all those replicas in sync. What happens if messages are being missed for 1 minute of time? This Kafka is down. Let's think about it, some network failure or something. For that 1 minute, thousands of write happen in the DB, and these replicas are never in sync, right? Even if these replicas are sync after 5 minutes or 10 minutes, it's okay, right? But let's say this Kafka comes back after some point of time. The newer messages are available by some way. I'm not getting into the complexities, right? But the older message, the time when some network failure happened, those older messages within that 1 minute of time is will never be available, right? So for that we have something called a reconciliation process. So you would have seen in my previous system design discussions as well, I always consider pointing out this problem statement with eventual consistency with the interviewer, and consider introducing the reconciliation as a backup process. This reconciliation process would be a cron job or any services which would run periodically and fetch these records from the primary DB and puts up in the secondary DB. Right? It can put up into the secondary DB, or it can write to the Kafka as well. Since it is a backup plan, we can write at multiple places. So ultimately this is gonna overwrite. So it's okay, right, to overwrite multiple times to making sure that the data is always available, even though if it is available after few seconds of time, it's okay, but we wanted to provide a mechanism to have this data available and not missed any data at any point of time. Okay, let's think about any other area of improvement that we can discuss as part of deep dive. Yeah, I can see one more area is when the data size is too large, right? Like after 5 year, 10 year, uh, do we wanted to expire the shortening URL, right? Maybe we wanted to give some expiry date for 30 days, 1 year, and if the data is expired, maybe we wanted to clean up the data, run the cleanup cron job periodically, which clean up the data, right? Also, if you wanted to partition the data, if it will not fit into a single instance of machine, then you can talk about the partitioning the database into a multiple instances. Then you talk about the sharding strategy. But when you have a sharding strategy, you will introduce another problem, right? How do you check with what would be the sharding key with the short URL or the long URL? But this is what the trade-off which you can make, and the and it's not about the right or wrong. It's about what you are thinking and what are the solutions you are proposing, keeping the trade-off in your mind. And if you are proposing a solution, what complexity it will introduce, how you are communicating with the interviewer, and how you are showing your seniority level for giving the decisions, what are the choices you make. So with that, let's get into our last step, which is the engineering excellency of the system. We will not get too much into detail about the engineering excellency, as we have already spent too much time in this video for the core concept and other part of the system. So we will quickly go through it so that it will not remain untouched. So this needs to be discussed at the end of the interview, even if you have a minute to have something added as part of your discussion. So just point out like how you are logging. You would be enabling the logging for your system. You would be looking for monitoring and health check of the system. The areas what we have discussed, if if some part of the system is down, and creating the alerts if some part of the system is down, so that a developer or a support team can act upon it to avoid any real customer impact. Let me summarize here how we started getting the requirement of the system here. So we started with the getting the functional requirement. We at this point of time, sometime there are some topics which you are new to it, right? So that's my recommendation approach, to start with something simple by making a note of what is the core functionality of the system which interviewer is looking for, and talking about the non-functional part of it that you are thinking for the scalability, performances, and about the consistency and availability of your system. Because why you are discussing at this point of time as a format I suggest is because at later point of time, when you get into the complexities of the system, you might not get chance to speak about it, and this is a time where you would talk about it, so that you do not need to think about it at a later stage point of time. Then you start with something what you know, that what is the data you can see while you are discussing about the problem, and how you wanted to have this data available to the clients or customers to consume. and without thinking about how you would make this data like available, what and how you are doing it, right? This is about what you are doing it. This is not about how you are doing it. Once you are discussed and you get the overview of the problem statement, then you get into like how you will make this data, or how you will do the processing, how you will implement this, considering the trade-offs in back of your mind. Then you will start something very simple to connect the dots of the points what you have discussed so far. Then you get into the deep dive, and there is no yes or no, right or wrong about the suggestions and proposals what you are making. It's about the choices and what are the trade-offs and what are the problems and solution you can think about it. And at the end, just touch upon the engineering excellency, which shows your seniority level and how broader you can think about it. What are the ownership skills you have when you take any feature live into the production. I hope you would have learned something today. Please like, subscribe to this channel and follow me to get more such content related to system design in future. Thank you. Bye bye.